Chapter 3 Electrochemistry 3.3 Electrolytic Cell Part 2. At the end of this Part 2 lecture, students should be able to predict the electrolysis of the following electrolytes using inert electrodes. The electrolytes are molten salt, water, concentrated and diluted aqueous sodium chloride, and aqueous sodium sulfate. Predict the products of electrolysis using appropriate examples. Predicting the products of electrolysis. First, when molten or liquid NaCl is used as electrolyte, the ions that exist are Na+ and Cl-. The electrode used is inert, such as carbon. The setup of the electrolytic cell is as shown. At anode, the ions attracted to it is the Cl-, while at cathode, the ions attracted to it is Na+. Therefore, the Cl- at anode will undergo oxidation to produce chlorine gas. On the other hand, at cathode, the Na+ will undergo reduction that will produce Na metal to be deposited. Second, predicting the products of electrolysis when water is used as the electrolyte. Pure water is a poor conductor of electricity. Therefore, a dilute acid such as sulfuric acid needs to be added to the water. So the ions that exist in the electrolyte are H2O and SO4 2-. The electrode used is inert, such as carbon. The setup of the electrolytic cell is as shown. At anode, the ions that will be attracted to it are H2O and SO4 2-, while at cathode, the ions attracted to it are H2O. At anode, between the two competing species, only the H2O ions are selected to be discharged. This is because the SO4 2- ions are hard to oxidize. The H2O ions will undergo oxidation so that oxygen gas is liberated at anode. On the other hand, at cathode, the H2O ions that will be discharged will undergo reduction so that hydrogen gas is liberated at cathode. Third, predicting the products of electrolysis when concentrated sodium chloride is used as the electrolyte. The ions that exist are Na+, Cl-, and H2O, and the electrode used is inert, such as carbon. The setup of the electrolytic cell is as shown. At anode, the ions to be attracted to it are Cl- ions and H2O, while at cathode, the ions attracted to it will be Na+ and H2O. At anode, only the Cl- ions are selected to be discharged because it is more concentrated and because the E node or SRP values are almost similar between the two competing species. So, the Cl- ion will undergo oxidation and chlorine gas is liberated at anode. On the other hand, at cathode, only the H2O ions are selected to be discharged because the E0 or SRP value of H2O is more positive than that of Na+. At cathode, the concentration factor is no longer significant because the E0 value are significantly larger between the two of them. The reduction that occur at cathode will produce hydrogen gas. Next, predicting the products of electrolysis when the electrolyte used is a diluted NaCl. The ions that exist are Na+, Cl-, and H2O, while the electrode used is inert, such as carbon. The setup of the electrolytic cell is as shown. The same ions will be attracted to the anode and cathode, just like the case in concentrated NaCl. The only difference is, because this is diluted NaCl, at anode, only the H2O ions are selected to be discharged, only because its SRP value is more negative. The H2O will undergo oxidation, so oxygen gas is liberated. On the other hand, at cathode, the H2O ions are selected because its SRP value is more positive, so the H2O will undergo reduction and hydrogen gas is liberated. Fourth, predicting the products of electrolysis when sodium sulfate aqueous is used as electrolyte. The ions that exist are Na+, SO42-, and H2O, while the electrode used is inert, such as carbon or platinum. The setup of the electrolytic cell is as shown. The ions attracted to anode will be SO42- and H2O, while the ions attracted to the cathode will be Na+ and H2O. At anode, only the H2O ions are selected to be discharged because the SO42- ions are very hard to be oxidized. Therefore, the H2O ions will undergo oxidation and oxygen gas is liberated at anode. On the other hand, at cathode, the H2O ions are selected to be discharged because its E0 or SRP value is more positive than that of the Na+ ions. The H2O will undergo reduction so that hydrogen gas is liberated at cathode. Next, we look at the application of electrolysis. The most common application is known as electroplating. So what is electroplating? It is a process of which there is a thin coat of metal to be applied to an object. The object that needs to be plated will be placed in a solution that contains the metal ions, causing the metal to be deposited on the object. The setup of electroplating process is as shown. In this example, a key is placed at the cathode and silver metal is placed at the anode. At the end of this electroplating process, silver metal will be deposited on the key. Other examples of electroplating is gold-plated watch, copper-plated mug, and silver-plated teapot. End of part 2. To be continued in part 3.